So welcome you all for the lecture. The topic of the lecture is carbines, carbanions, and free radicals. So in this lecture, we will discuss about the carbines, and free radical. Before this, we will go with some of the some of the basics about the intermediates because these all are the intermediates. So here, if you see, the content of the topics is reaction intermediate, among them carbene, their generation, structure, and stability, and carbanions. And in carbanions, you can see here, uh, if you see, these are formation, structure, reaction involving carbines. Here you all might be aware of that intermediate, because these are the intermediates all. So these intermediates, these are the atoms, ions, and molecules with a lifetime appreciably longer than a molecular vibration that is formed directly or indirectly from the reactant and reacts further to give either directly or indirectly the process of chemical reaction. So these are the intermediate which form during the course of a reaction. So during the course of a reaction, they plays a very important role to decide the formation of a particular chemical products. So these intermediate are having very crucial roles during the chemical synthesis. So here, if you see, so now coming to, before going to carbanion and carbines and free radical, which is the lecture of the topic, here you have to be some prior knowledge of carbocation. So here, carbocation, you all might have know, is having electron deficient species, so represented by this structure, and having planar planar structure and sp2 hybridized. So these carbonium ion are trivalents, positive species like methyl positive, ethyl positive, and pentavalent positive species. So these are the general structure which is looks like here. If you see triphenyl, methyl, three different phenyl groups are there. And if you see their hybridization, you can see the hybridization is sp2 hybridized. So there are many more example is there which you can see how the carbocation is being formed. So these are having a very great importance during the course of reaction. If you see their formation, there are number of techniques for the formation of these. So here you can say by the halide, alkyl halides, you can synthesize the carbocation. And likewise, there are number of other reaction like alcohols, like methyl alcohol and other. So you can also produce these kind of species. Here you can say like from the different amino groups, if are amides, are sh. So from these type of starting material, you can also synthesize these carbocations. So there are a way of formation of this. So they can react with the nucleophiles if it is having any in a reaction in a nucleophilic group. So they can get attached with the nucleophile. So some carbocation act as a proton state acid to lose the proton. So here you can see some are losing the proton and keeping their electrons. So they are releasing a proton, so acting as Brown state acid as well. So here stability, if you see, the tertiary carbocation is more stable than secondary and primary. So this is due to the hyperconjugations. You might have some idea about the previous classes and from the previous lecture as well. So here these are the the compounds which is having very great relevance with respect to once we are talking about the carbocation. So their stability also depends upon the number of hyperconjugating structure which is having the more in that case. So here in a case of like tertiary, you can say also in case of tertiary carbon and secondary carbon and primary carbon. So accordingly their stability is being decided and they are having the more stability. So now coming to carbanion, the carbanion is an anion which the carbon has an unsaid pair of electron. So this is having B as a negative charge, usually with the 3 substituent for a total of the 8 valence electrons. So formyl, like formally if you say a carbanion is the conjugate base of carbon acid. So here if you see this carbon is attached with the alkyl group and this is attached with another groups. So here you can say there is a one lone pair of electron. So this is carrying negative charge. So here this is like a conjugate base, you can see. So stable carbanions to however exist, although in this most cases they are reactive. So there are many reactions in which the carbanion, you can say here in this reaction, here it is also like crown ethers, if you have idea about this. So these are the crown ethers. So here with in the presence of this molecule which is having triphenyl groups, so they are in presence of n-butyl lithium and tetrahydrofuran. These are the reagents. So this is making this carbanion species. So these are the formation by which these carbanion species can be synthesized. So here they can make a ionic bond with the lithium which is present in a reagent butyl lithium and butyl lithium. So this is a carbanion formation here in case of triphenyl groups attached in this compound. So by this way they can be also generated by the different of different reaction, and their reactions you can see here, like by replacing the hydrogen from the from the hydrocarbon, because this is the hydrocarbon chain R, and this can be generated from there also. So a group attached to the carbon leaves without its electron pair, because here hydrogen is removing or from this by the leaving their electron to this carbon. So then these can be formed. So a negative ion adds a carbon carbon double or triple bonds. So now you can see here like from this group, so this can also RCO. So here this R is being replacing by taking the electron due to the electron density moving this direction due to the high electronegative atoms. So this is also making a carbanion. So there are number of methods by which these can be generated. These reaction can be, or carbanion can be generated. Likewise here you can see these groups can, if there is any negative or nucleophile kind of groups is attacking with a particular carbon, so the electron will shift towards this carbon. So this will also make a carbanion species, which is this carbon. So here you can see there are many more examples for this, like alkyl chlorides in the reaction with lithium and with magnesium. You can see that these can give such kind of reduce the strongly reduced metal like lithium, and sodium or magnesium can convert alkyl halide to alkyl sodium or alkyl lithium. So here if you are reacting with the sodium, it will make a alkyl sodium, or if you react with the lithium, it will make it these kind of compound. So other other there are many more examples of the reactions which the carbanion takes place. So here the carbanion can react with the alkyl chloride and can make the alkyl chain. So this is the hydrocarbon chain will be formed up, and finally, so it means this is having the application for also the formation of the hydrocarbon. So you can synthesize the hydrocarbon as well. So this is having the great another application for the hydrocarbon industry, because the hydrocarbon industry is having very great role for the formation of different kind of polystyrene polymers and hydrocarbon, like gaseous fuels. So even for these kind of synthesis, and many more products can be synthesized in biorefinery industries. They are having very crucial role. So here similarly this kind of reaction, you can see this is the carbon and carbon. So this can bromine with reacting with the bromine, they can add the bromine from this side. So bromination can takes place by this way. So this is having another one excellent example. So in case of the carbanion may undergo catinotropic 1,2 shift to give a rearranged product. So here you can see how does the 1,2 shift is being taking place. So you can see here this group is shifting over here. So and this is this is here, you can see here. So this is just this carbon is getting over here. You can see here this methyl is now attached with this one, this phenyl group. So this kind of shift is also rearrangement type of shift, you can say, is rearranging over here in this. So the carbanions may oxidize to free radical. For example, you can say free radical can be oxidized here. So this can make it like this kind of reactions as well. So if you see, in case of stability, the stability of carbanion is directly related to the strength of the conjugate acid. So here you can see the stability order, how the weaker is the acid, the greater is the base strength, and the lower is the stability of the carbanion. So you have to see here, if the weaker is the acid, the greater will be is the base strength, and the lower is the stability of carbanion. So stabilization by the sulfur or phosphorus, other metals can stabilize that carbanion, but that depends upon if it is present in the reaction. So then only that can be stabilize the particular molecules, or carbanion in a molecule also. So if you see the field effect, ylides are the more stable than the corresponding simple carbanions. So carbanions are stabilized by field effect if there is any heteroatom. Means if there are any heteroatoms, so carbanion are stabilized due to the field effects uh, connected to the carbanion, ionic carbon. So provide that the heteroatom be as a positively charged in at least one important canonical form. So here you can see how does these changes are being can takes place. They can exist in different canonical forms. So even though they can be having the this kind of effects, field effects also, that particular carbanions on the presence of heteroatoms. So stability, as we said, so conjugation of unsaid pair of electron with an unsaturated bond. So here you can say unsaturated bond, you can conjugation if they are in a conjugation mode. So like here the conjugation is possible. So they can also stabilize the carbanion if there is a conjugation. So similarly here you can say there are number of conjugating structure is possible. So that in that case that carbanion will be more stable. So if you see in a different group, so like in a triple bonded compound will be more stable than second double bonded and aromatics, carbanion and RCS2 simple alkyl. So carbanion increase in stability with increase in the amount of S character. So you have to see if there are higher the S character, so there will be the more of the carbanion will be more stable. So here in triple bond you can see, and different other groups you can also check their S characters. So the accordingly the that particular species of carbanion will be more stable. So carbanion factors, there are number of stability and reactivity, which like inductive effects, hybridization and extent of conjugation, and the so electronegative atom adjacent to the charge will stabilize the charges. Obviously this will inductive effect. In case of inductive effect, hybridization, charge bearing atom, the greater is the sp3 character or sp character of the charge bearing atom, the more stable the anion. So the extent of the conjugation of anion, resonance effect and stabilizing of the anion also will stabilize the molecule. So how to detect these carbanions? There are a number of techniques like NMR methods, nuclear magnetic resonance spectroscopy, ultraviolet visible spectroscopy. So these are some of the important techniques by which or visible spectra can also determine the starting compounds. And trapping way, the method of trapping of the carbanion with an electrophile is another way of, to detect the carbanions. So there are the most advanced technique you can see here like nuclear magnetic resonance, ultraviolet. So these all material has been taken from the different sources, internet sources, from the other sources, different textbooks. So the this has been taken from various internet sites. So this text material is only, or this instruction material is for only instruction purpose only. So here, thank you for watching this video and listening this video lecture. Thank you so much.